From the 14th century to the 19th, Europe endured what historians call the Little Ice Age, a long era of brutal winters, shortened summers, and relentless cold that reshaped daily life. Rivers froze solid for months at a time, harvests failed repeatedly, and survival depended less on strength than on knowledge. In England, winter temperatures often remained below freezing. In France, 15 degrees Celsius was common, and in Scandinavia and Russia communities adapted to life at 40 degrees Celsius. People did not survive these conditions by accident. They survived because they learned how to create, store, and release heat, using systems that worked without electricity, fossil fuels, or modern machinery. Homes were built to trap warmth, not to display wealth. Thick stone or timber walls acted as thermal mass, absorbing heat from fires during the day and releasing it slowly through the night. Small shuttered windows reduced heat loss. Roofs were steep and insulated with straw, turf, or packed earth. Fireplaces were engineered to radiate heat inward rather than wasted up the chimney, and in many regions, hypocaust-style floor heating, masonry stoves, and enclosed hearths warmed entire rooms with a single fire. Clothing was layered intelligently, using wool, fur, and linen in combinations that managed moisture and body heat far better than many modern fabrics. Food preservation, smoking, salting, fermenting, was also a thermal strategy, reducing the need for constant cooking fires in winter. Crucially, this knowledge was not random or primitive. Monasteries, guilds, and craftsmen carefully documented these techniques, drawing diagrams, writing manuals, and passing practical wisdom from generation to generation. Heating was treated as a system, not a convenience. Then, after 1900, everything changed. Central heating, cheap fossil fuels, and later electricity transformed buildings into heat-dependent machines. By the 1950s, much of Europe had forgotten how to live without constant external energy. Homes became lighter, thinner, and less resilient, designed to be comfortable only when power flows uninterrupted. The old knowledge, how to stay warm when fuel is scarce, how to design a house that cooperates with nature instead of fighting it, was dismissed as obsolete. Today, the consequences are visible. When power fails, even expensive modern houses can become deadly within days, turning into cold, uninhabitable shells. Meanwhile, medieval people, often poorer with fewer resources, endured harsher climates using simple, durable, and effective systems that required no grid, no engines, and no modern technology. The lesson of the Little Ice Age is not that medieval Europeans were tougher than us, but that they were smarter about heat. They understood that survival depends on systems, not comfort, and that resilience comes from knowledge that works even when everything else stops. At the heart of medieval domestic heating stood the central fire pit, a simple ring of stones set into the middle of the floor, with a smoke hole cut into the roof above. By modern standards, this system was inefficient. Much of the heat escaped with the smoke, and temperature control was crude, but it had two qualities modern systems often lack: reliability and resilience. Fuel was usually local and essentially free, gathered as wood, peat, or agricultural waste, and the system itself could not truly fail. There were no pipes to burst, no wires to short, no external supply chain to collapse. Fire was communal knowledge. At night, glowing embers were carefully buried under ash to preserve heat until morning, and if a household's fire died, someone would simply walk to a neighbor and borrow embers. Entire villages functioned as shared thermal networks, sustained by cooperation rather than infrastructure. Medieval people also understood a principle largely forgotten today: you do not need to heat the entire building to survive the night. You need to heat the human body. After sunset, priority shifted from warming the house to warming the bed. Warming pans filled with hot coals were slid between blankets, heated stones were wrapped in cloth, and soapstone blocks, dense heat-retentive material, were placed near sleepers. These stones absorbed heat from the fire and released it slowly for 6 to 12 hours, providing steady warmth through the coldest part of the night. This was not a desperate improvisation, but a refined practice, repeated for centuries and optimized through experience. Soapstone warmers were especially valued because they did not spark, burn fabric, or require constant attention. Compare this to modern electric blankets. They provide quick comfort, but only as long as electricity flows, and they introduce risks of fire, overheating, and mechanical failure. Remove the power and they become useless weight. Meanwhile, soapstone warmers made 200 years ago still sit in museums today, perfectly able of doing the job they were designed for. Medieval heating culture favored durability, simplicity, and safety over convenience. Objects were built to last decades, sometimes lifetimes, because replacement was expensive and resources were finite. Modern society has made the opposite choice. We have traded systems that degrade gracefully for systems that fail catastrophically. We have chosen disposable solutions, cheap to buy, expensive to depend on, that work brilliantly under ideal conditions and dangerously under stress. The medieval household accepted lower efficiency in exchange for independence. Their heating methods were slower, rougher, and less uniform, but they worked in blizzards, fuel shortages, and social collapse. The real loss is not comfort, but knowledge, an understanding that warmth is not a switch you flip, but a process you manage through materials, habits, and shared responsibility. In abandoning that mindset, we did not become safer or smarter, we simply became more fragile. Europe's greatest pre-industrial engineers did not chase instant warmth, they engineered time. Their most impressive achievement was the Masonry stove, a massive structure of brick, tile, and stone designed to act as a thermal battery. With only 1 or 2 hours of intense fire, these stoves could release gentle, even heat for an entire day. German Kachelofen stoves and traditional Russian masonry stoves regularly achieved efficiencies above 95%, capturing almost all the heat from burning wood and storing it within their dense walls. In contrast, most modern open fireplaces waste energy spectacularly, losing 85 to 90% of their heat straight up the chimney. Medieval and early modern builders understood that flames are not the goal, stored heat is. The fire was burned hot and fast, the smoke carefully channeled through internal flues, and the warmth absorbed into masonry that slowly radiated heat long after the fire was gone. This made homes quieter, cleaner, and far safer, with no need to tend flames through the night. These stoves did not exist in isolation. They worked as part of a complete building system. Thick thatched roofs trapped warm air while still allowing moisture to escape, preventing rot and mold without plastic vapor barriers. Cob and earthen walls, made from clay, straw, and sand, acted as both insulation and thermal mass, smoothing out temperature swings across day and night. These materials breathed naturally, regulating humidity and indoor air quality in ways modern sealed houses often fail to do. All of this was achieved without foam insulation, synthetic membranes, or chemical treatments. The result was homes that were warm, dry, and remarkably durable. These domestic systems were not experiments. They were proven technologies that functioned for centuries. Masonry stoves were routinely passed down through generations, repaired rather than replaced, and expected to last a lifetime or more. Compare that to modern heating systems, which are often designed for a lifespan of 20 to 30 years before being ripped out and sent to landfill. Today's houses rely on complex machines that demand constant energy input and specialized maintenance, while medieval systems relied on physics, materials, and craftsmanship. Ironically, many of these highly effective old solutions are now restricted or banned by modern building codes, not because they were unsafe, but because they worked too well outside centralized energy systems. Their efficiency reduced fuel consumption, their durability reduced dependence on constant upgrades, and their independence conflicted with modern infrastructure and regulation. The loss is not merely historical curiosity, it is practical knowledge. In an age of energy uncertainty, the medieval approach offers a powerful reminder. True engineering is not about maximum output, but maximum resilience. These builders created homes that cooperated with nature, stored warmth intelligently, and endured for centuries. While much of what we build today is already aging toward obsolescence, the most powerful and misunderstood heating technique used in medieval Europe was the semi-underground dwelling, known to archaeologists as Grubenhaus. These were not primitive shelters dug out of desperation, but deliberately engineered homes built half below ground level to exploit one of the most stable energy sources available, the Earth itself. Just a short distance beneath the surface, soil temperature remains remarkably constant throughout the year, hovering around 12 to 13 degrees Celsius, regardless of whether the air above is scorching or frozen. When winter temperatures dropped to 20 degrees Celsius or lower, a semi-underground house began the day already warm by comparison. This single design choice radically reduced the energy needed for survival. With fewer walls exposed to wind, there was far less heat loss. Cold air could not easily strip warmth from the structure, and the surrounding earth acted as a vast thermal buffer, absorbing and slowly releasing heat over time. Inside, clay ovens, earthen floors, and packed soil walls functioned as natural heat stores, capturing warmth from small fires and radiating it back into the living space for hours. As a result, just 1 or 2 modest fires per day were often enough to keep the entire dwelling comfortable, even during severe cold spells. Archaeological evidence consistently shows that communities using semi-subterranean housing experienced higher survival rates during periods of famine, fuel shortage, and extreme winter. These homes required less wood, less labor, and less daily effort to maintain livable conditions, giving their occupants a crucial advantage when resources were scarce. Medieval builders intuitively grasped something modern society often overlooks. Heating efficiency is not only about insulation values or fuel output, but about starting temperature and thermal mass. A house that begins at 13 degrees Celsius and loses heat slowly is fundamentally easier to keep warm than a house that starts at 0 degrees Celsius and leaks heat in every direction. Today, we obsess over insulation ratings, thin walls packed with foam, and complex mechanical systems designed to force heat into fragile structures. Medieval people approached the problem from the opposite direction. They shaped the building to work with natural temperature stability, not against it. This knowledge was not lost because it failed. It was forgotten because industrialization favored speed, uniformity, and above-ground construction suited to centralized utilities. Over time, Earth-integrated designs were dismissed as outdated, unhealthy, or socially undesirable, despite centuries of proven performance. Yet modern science has quietly confirmed what medieval builders already knew. Thermal mass, ground coupling, and passive heat storage are now core principles in sustainable architecture and energy-efficient design. Engineers model them with software, universities teach them in textbooks, and governments fund research to rediscover them, often under new names. The uncomfortable question remains, if these systems are now scientifically validated, resilient, and energy efficient, why do we continue to ignore them? Perhaps the issue is not feasibility, but mindset. Medieval builders designed for endurance in a hostile world. Modern society designs for convenience in a stable one. As that stability weakens, the wisdom buried in the ground beneath our feet may once again become impossible to ignore.